66 million years ago, something entered Earth's atmosphere at 20 kilometers per second. It was roughly the size of Mount Everest, and by the time anything on the surface could react, by the time a single nerve impulse could travel from a dinosaur's eye to its brain, the world had already ended. This is what the science says happened next. The Chicxulub asteroid didn't just hit the Earth. It punched through the atmosphere so fast that the air in front of it couldn't move out of the way. It compressed, it superheated. And then the asteroid, 12 kilometers wide, made of rock and metal, struck what is now the Yucatan Peninsula in Mexico, with a force equivalent to 10 billion Hiroshima bombs going off at once. Not over time, simultaneously, in under a second. The ground didn't just shake, it ceased to exist. And what followed over the next 24 hours would be unlike anything this planet has experienced before or since. The discovery that led us here came from a layer of clay. In 1980, physicist Luis Alvarez and his son Walter, a geologist, were studying sediment at the boundary between two geological eras, the Cretaceous and the Paleogene. At that exact boundary, in samples from around the world, they found a thin, uniform layer of iridium. Iridium is rare on Earth's surface. It's common in asteroids. The concentration they found was 30 times higher than background levels, and it appeared everywhere simultaneously. Italy, Denmark, New Zealand, the American West. The same thin layer of alien metal deposited at the same moment in geologic time on every continent on Earth. Something massive had hit the planet, something that left its chemical signature in the rock record worldwide. We eventually found the crater. It was hiding beneath the Gulf of Mexico, centered on the Yucatan Peninsula. 180 kilometers wide, 20 kilometers deep at the point of impact, the largest confirmed impact structure on the planet. When geologists drilled into the crater floor decades later, they pulled up rocks that had been melted, vaporized, shocked into forms that don't exist in nature under normal conditions. One of those rocks, called suevite, contains glass beads, droplets of the asteroid itself, fused with the vaporized Earth and scattered across thousands of kilometers, frozen mid-flight, the physical record of the worst day in the history of complex life. Now try to understand what that first minute actually looked like. The asteroid strikes. At the moment of contact, the energy transfer is so extreme that both the asteroid and several kilometers of Earth's crust are instantly vaporized. Not melted, vaporized, turned directly into a plasma cloud that expands at hypersonic speed. A fireball rises into the atmosphere within seconds. The ground around the impact site ripples outward like water. The rock itself behaves like a liquid, collapsing inward, then rebounding upward into a temporary mountain kilometers high, before collapsing again into a ring. All of this happens in under 2 minutes. The pressure wave travels outward through the ground faster than sound. Anything within several hundred kilometers is simply erased by the seismic energy alone, equivalent to a magnitude 11 earthquake, a number that sits beyond our instruments' ability to even measure. The ocean surrounding the Yucatan reacts like a bathtub that's been struck from below. Mega tsunamis, walls of water hundreds of meters tall, radiate outward in every direction. They cross the Gulf of Mexico in hours. They slam into coastlines across North America, South America, Europe. The evidence of these waves, boulders and sediment and marine fossils deposited hundreds of kilometers inland, is still visible in the geological record today. Before you subscribe, I want to ask you something. What subject should we cover next? Drop it in the comments. All ideas are welcome, and more than a few of our videos have come directly from you. If you haven't subscribed yet, now is a good time. This is the kind of story we do every week. But the seismic wave and the tsunami, as catastrophic as they are not what kills the planet. What kills the planet is what happens next in the sky. Within the first hour of impact, the asteroid ejects billions of tons of debris into the atmosphere and beyond. Chunks of rock and condensed droplets of vaporized crust are launched on ballistic trajectories, some of them reaching space. Over the next few hours, this material re-enters the atmosphere all over the world. Everywhere, not just near the impact site. The sky becomes a global rain of superheated rock. As each piece re-enters, it heats the air around it through friction. The upper atmosphere glows. The temperature at the surface of the Earth, driven by the infrared radiation from this incoming debris, rises by hundreds of degrees in some models. It's not a fire that spreads from place to place. It's a global oven, turned on all at once. Forests ignite spontaneously across entire continents. Animals in the open have no shelter. Anything that survives the first impact event and the tsunamis now faces an atmosphere that is, briefly, hotter than an oven. This phase lasts hours. Then something worse begins. The impact vaporized billions of tons of sulfur-rich rock. That sulfur enters the atmosphere as sulfur dioxide, which reacts with water vapor to form sulfuric acid aerosols. Combined with the soot from the global wildfires and the dust still suspended from the impact itself, the sky goes dark. Not dim, dark. The sun disappears. For months, possibly years, the light reaching Earth's surface drops to near zero. Plants cannot photosynthesize. The food chain from the bottom up collapses. Global temperatures plummet. Acid rain strips nutrients from soil. The oceans acidify. In the darkness, the planet freezes. 3/4 of all species on Earth go extinct. Not gradually. Within thousands of years, a geological eye blink, they vanish from the fossil record. The non-avian dinosaurs, who had dominated for 165 million years, are gone. The large marine reptiles, the flying pterosaurs, the ammonites, entire families of life that had survived previous extinction events, previous ice ages, previous catastrophes, gone. But here is what the science asks you to sit with. That impact, the worst thing that ever happened to complex life on Earth, also created the opening. In the darkness and the cold, small burrowing mammals survived. They could eat seeds, insects, roots, things that stored energy. They didn't need sunlight directly. And when the sky finally cleared, when the first light reached the surface again after months or years of dark, those small creatures emerged into a world with no large predators. Every ecological niche on land suddenly opened. What followed was an explosion of mammalian diversity unlike anything before it. The impact didn't just end a world. It started the one that would eventually produce us. Every mammal alive today, every whale, every bat, every primate, every human being, is descended from something that survived that darkness. Something small enough to hide. Something that waited. The asteroid didn't ask what it was going to kill. It didn't aim. It arrived because orbital mechanics brought it here, as they bring everything eventually, and it struck a planet full of life at exactly the wrong moment for the creatures that couldn't adapt, and exactly the right moment for the ones that could. We sit here asking questions about it because of a rock that fell, and a world that ended, and a few small, warm-blooded animals that found somewhere to hide when the sky caught fire. That's not a tragedy. That's the whole story.